With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Our question is, when dimethyl glyoxime is added to the aqueous solution of nickel 2 chloride in presence of dilute ammonia solution, a bright red colored precipitate is obtained. First part is, draw the structure of bright red substance, then write the oxidation state of nickel in the substance and hybridization, then state whether the substance is paramagnetic or diamagnetic. So we over here are given this reaction and we are supposed to find out the product of it, right? First of all, if we talk about the reaction, they are saying that when dimethyl glyoxime, that is DMG, is added to the gaseous solution of nickel 2 chloride in the presence of dilute ammonia, bright red color precipitate is obtained. So what is the reaction actually over here? The reaction is that we have NiCl2, right? This is reacting with dimethyl glyoxime, right, in presence of dilute ammonia, and we are getting something, right? So we have to find out the product. So over here what is happening is that Ni2 positive, that is our nickel in +2 oxidation state, this is reacting with our DMG, right, and forming NiDMG whole twice, right? So we have 2 DMG over here. So the nickel, when reacts with DMG, it forms this kind of complex NiDMG whole twice. This is the red precipitate that we are getting. This is bright red in color. So this is our product that has been formed, right? So first part was that we need to draw the structure of the bright red substance, right? Now what is DMG? DMG is dimethyl glyoxime, right? So what we have is that we have nickel 2 positive, right, and this is forming bonds like this. We have basically bond with nitrogen of this part, right? We have CH3, we have carbon over here, we have CH3, right, and then over here also we have nitrogen, right? This have OH attached to it, right, and this have this O negative, right? Similarly in this case we're gonna have bonds with nitrogen that is attached to carbon. We have CH3 over here, then over here we have carbon that is attached to CH3, right, and over here this is doubly bonded to nitrogen. We have O negative attached over here and OH attached over here, right, and over here we see hydrogen bonding with them, right? So this is basically the structure of NiDMG whole twice, right? The second part was to write the oxidation state of nickel. We see that we have oxidation state of 2 positive in this case. Then we are supposed to tell that what is the hybridization. So how can we find out the hybridization? We know that nickel has atomic number of 28 and has a valence electronic configuration of 3d8 4s2, right? So 2 electrons would get lost from here, and we're gonna have 3d8 as electronic configuration for nickel 2 positive, right? Over here the coordination number would be 4, right? We can see that the coordination number is 4, right? But over here we have chelation present in the compound, so we gonna have pairing in the electrons over here, right? So if we draw the orbitals, we have 3d orbitals, then we have empty 4s orbital, and then we have empty 4p orbitals. So the pairing of electrons is gonna occur like this. We're gonna have 8 electrons over here, then it's gonna make 1 2 3 and 4 bonds, right? So this gonna have DSP2 type of hybridization with square planar geometry, right? So this is what, this is square planar in nature, and the hybridization is DSP2. Then the third part is that state whether the substance is paramagnetic or diamagnetic. Now over here all the electrons are paired, right? Our n value is 0, and our what, number of unpaired electrons? We do not have any unpaired electrons. All the electrons are paired, and hence we can say that this is a diamagnetic species, right? So these are our answer to the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.